So, can we always assume that a distribution is normal without checking the data? The answer to that is always and always will be no. In all capital letters with several exclamation marks, you may not assume that a distribution is normal just because it looks like it's unimodal and symmetric. That does not mean it's normal. So how can you determine if it's normal? There are two ways. One, you can check the empirical rule. You can count the data points and divide between one standard deviation and make sure that it is close to 68%. 2 standard deviations should be close to 95%, and 3 standard deviations should be close to 99.7. Or you can create a normal probability plot. These are fabulous. Okay, you're not going to have to use them a lot unless you just want to right now, but they do come into play in the spring with some stuff we were doing in the very last chapters of the book. So these right here are great, and I think they are a lot less work than having to count up and divide all your points to check those 3 different sections. So let's look and see how this works. This is a sample of 36 side-by-side refrigerators. And what they do is they describe the usable capacity. This is from Consumer Reports. And we want to know, is this data close to normal? So I'm going to put this into a list in my calculator. And I'm going to do one variable statistics. And it tells me that my mean is 15.825. And it tells me that my standard deviation is 1.217. Notice the S and the X bar because this is a sample. Okay, and I can check it with the empirical rule. So if I know my mean is this, then I can look one standard deviation back, and if I did my subtraction and one standard deviation above, that means that I would need to count the numbers between 14.608 and 17.042. Okay, if I count those, I get 24 out of the 36, which is approximately 66.7%. Okay, that's pretty close. Okay, 2 standard deviations would be 13.391 and 18.259. Okay, that's 34 out of the 36, which would be about 94.4%. Okay, again, pretty close to 95. 3 standard deviations would be between 12.174 and 19.467. That's all of the points, and so that's 100%, also close. Okay, while these are not right on the money, they are only within 2 percentage points at the most of what they should be. So we can assume that this probably, based on the empirical rule, is approximately normal. Okay, I know that seemed like it went pretty fast, and you're saying, oh, that's no big deal. But I had already counted these up before I started the video because I did not think that you would want to sit here for 5 minutes and watch me count. So it does take a little bit longer time than what I've just shown. Okay, but it is a totally okay process to do to decide if data is normal. So what the other option is a normal probability plot. Okay, to create a normal probability plot, you are going to create a graph. And it's a lot like a scatter plot. And in your scatter plot, you want your z-scores to be on the y-axis. So I'm going to take every one of those pieces of data and I'm going to calculate its z-score. So for, I would say, 12.9 minus the mean divided by the standard deviation, and I would get a z-score. And whatever that z-score I got was, I would graph it with the z-score on the y-axis and the data on the x-axis. So I would go to wherever 12.9 was, and I would go up, and I would put a dot. Okay, if you have a calculator, this is much easier to do. I have put all of my values in this list here, okay, in A. And what I'm going to do now is I'm going to create a new page that is a data and statistics page. And I'm going to tell it that I want, I guess I need to give it a name. Let's call it fridge since it's refrigerators. Okay, I'm going to tell it that I want to graph my fridge data. Okay, that's it as a dot plot. I don't need a dot plot. So I'm going to hit menu and see how it gets plot type. I'm going to do a plot type and I'm going to pick normal probability plot. Okay, see how it gave me this, okay, z-scores on the y-axis, expected z's, fridge values on the x-axis. Notice how these form a pretty straight line. That's what we're looking for in a normal probability plot. If it is roughly linear, then your data is approximately normal. Okay, and look, it even gave you the formula for calculating the y values, which in this case are the z-scores. So, if these are approximately normal, then these are in a rough line. Okay, if I go back and I add some more data in here, and let's say, I add a lot towards the end. So 20.5, 23, 24, 50, 23.4. I'm just stacking them towards the end. Because if I have a lot of data on the end, then it's not normal because they're going to have some outliers, and we know that it does not have outliers. Excuse my grammar there. Got in a hurry. 25.3, 21, just stacking them up towards the end. Okay, now let's go look. And notice how I have this curve here. See these curves? Okay, and how it gives me this line right here. This is the line that I would want it to follow. This is what it actually follows. So that tells me that this data is no longer normal. So if you use a normal probability plot, and we're going to actually make some in class by hand, what you are looking for is a roughly linear pattern. If you see any dramatic curves like we can see here, then it's not normal.